Hello everyone. I'm going to take a look at an example where we're going to find the area of a sector. So just real quick, a sector is basically just a piece of the entire circle. So in my circle I have drawn here, circle T, one sector of this circle would be the region that's bounded by the radius UT, the one VT, and then the arc UV. So this region here, this is a sector of the circle, okay? When we think of a sector or like a slice of the pie, that's normally what we think of. But the other region, the rest of the circle, the Pac-Man looking piece, that is also technically a sector of the circle. So what I'm going to do here is I want to find the area of both of these. Now, just like we did with arc length, the area of this sector, this is just part of the area of the entire circle. So we're going to use that same relationship. So we know that pi r squared is going to give us the area of the entire thing. And then if I compare that area with my angle, my central angle, over 360, that's going to give me the area of just the piece that I want. So what we end up with, so then the area of sector, and then let's start with sector, so I'm going to name it just based on the 3 points that make this up, so the sector UTV. So the area of that is going to be equal to, so then we have the measure of our central angle, or the measure of our vector, so in this case here would be the measure of UV over 360 times pi r squared. So pi r squared, that gives me the entire area of the circle, and then this fraction is going to tell me the piece of the circle that we want. So if we plug in what we know, the measure of arc UV is 70 over 360, and then times pi times 8 squared. Okay, so let's see what we end up with. If I simplify a little bit, 70 over 360 is 7 over 36. So we can just cross out the zeros, and then times 64 pi. So yeah, if I break down these two pieces here, just the 64 pi, that's the area of the entire circle. But I'm not looking at the entire circle, I'm just looking at a piece of it. Okay? This fraction, this tells me how much of the circle I want. So my sector is represented by 7/36 of the entire circle. So 7/36 is, it's roughly, it's about 0.2. So we're looking at, about 20% of the circle. So let me just multiply these together. And if we do a little simplifying, we end up with 112 over 9 times pi. So that would be the exact area of the sector. And then if I get a rounded answer, we get the area is about 39.1 and inches squared. All right, so that's the area of this sector here. Now what I could do, if I want to find the area of the other sector, I could do this by doing the exact same thing. So the angle, the rest of this, 360 minus 70, so this has an angle of 290 degrees. So it would be exactly the same, but I would just replace the 70 with 290. Or, because I know altogether the area of this is going to be 64 pi, the piece I'm looking at here is 39.1. So if I want to find the area of the other sector, and let's see, how do we want to name this? So the area of the sector, So if, I don't want to just say UTV because we already named this one that. So we do have the other point here, so it's bounded by the major arc. So I'm going to say the area of the sector bounded by arc USV. So this is going to be equal to the area of the entire circle minus the area of the sector we already found. And that gives me a value of about 161.97. So then together, if I were to add these two pieces up, that would give me the entire area of the circle, which would be the same as 64 pi. So again, just using some things that we already know. Pi r squared, we know that formula. That gives me the entire area of the circle. And then we're just comparing that with the fraction, where we're comparing the measure of the arc to 360. And that tells me how much of the area I actually need for my sector.